Intermolecular forces are the forces between molecules. There are two types of intermolecular forces. There are dipole-dipole interactions, and there are London dispersion forces. Dipole-dipole interactions are when a molecule has uneven charges about its end. So something like water, it has a negative end and a positive end, or hydrogen fluoride, positive end, negative end. So as a result, the positive ends will be attracted to the negative ends of each other. It doesn't necessarily mean they have to be the exact same molecule, but something that has a positive end and a negative end, they'll attract to each other, whether it's just a bunch of water or if I have protons dissolved in here or something else. As long as the forces are of the same type, dipole-dipole, then they will be attracted to each other. And the other type of intermolecular forces apply to molecules that don't have dipole-dipole forces, where their charges are more evenly distributed, like in hydrogen gas. Since hydrogen is bonded just to itself, neither hydrogen is going to be able to attract the electrons more to itself than the other. So as a result, there's going to be no dipole-dipole interactions. But what can happen, since the electrons aren't in one place, while generally in hydrogen gas the electrons are more evenly distributed than in something like in water, there can be moments where there might be slightly more electrons on one side or the other of a molecule, even just for a fleeting moment. But that's all it takes. Let's say for just a second that in this hydrogen there were more electrons for the left side than the right side, just momentarily. But if this happens and it's next to another hydrogen, its temporary positive charge on one side will be attracted to the slightly higher electron density of the adjacent molecule. So what happens is that it ends up polarizing the other molecule slightly. Not a lot, just slightly is all that's needed. And now all of a sudden this molecule is slightly polarized, and then it'll polarize the next one, and the next one, and the next one. These forces are very, very weak. That's why things like nitrogen that are going to have the same kind of London forces as hydrogen gas have very, very low boiling points. It's like it's like 200 and something degrees. I can't remember what it is, but the point is that these forces are very, very weak, and these molecules will have to slow down a lot in order for these forces to take place. If these things are moving too fast or they aren't compressed enough, then even if there was a very temporary polarization in one of these molecules, unless it's very close to another one, then it won't have time for it to influence the other molecules. But those are the two main types of forces: dipole-dipole forces and London forces. And basically they're the same idea, except one has more natural dipole-dipole, has more natural separation of charges, where one end is negative, one end is positive, and in the other case, it doesn't naturally have them. It has to sit around and wait for an instance where just by chance one side is more negative and one side is more positive, and if other molecules are moving slowly enough and are close enough, then it can influence the other ones and cause the same thing to happen.